Any questions about anything before we get going? So I just wanted to also remind everybody that we won't be meeting like this on Friday for class. Ordinarily, for Good Friday, we would have Good Friday off anyway, so we won't be meeting as a class, but you should still feel free to email me, and if we need to discuss anything through Zoom or anything, we can definitely do that. I'll be available, but we won't be meeting as formally like a class on Friday. All right, so we talked last time about the law of sines. Which had this relationship between the angles and the sides of a triangle. So today, though, this was always, remember, it was always we had to have an angle and then its side opposite, an angle and its side opposite. If we try to apply this in this situation, notice that in this first triangle, we have the side opposite, capital C here would be little c. The angle at at A we typically refer to as alpha, and at B we typically refer to as beta. Notice in this case, I don't have enough information to allow me to use the law of sines to figure something out, because if I try to use angle at C, I don't know little c. And if I try to use any of the other ratios, I don't know one of the angles. So the law of sines is not going to help me figure out information about this triangle because I don't have enough information with the opposite sides and angles. So there must be another formula that we can use to help us solve these particular types of triangles. And this is what's referred to as the law of cosines. So usually we write it as c squared equals a squared plus b squared. Notice that this looks a lot like your Pythagorean theorem, the c squared equals a squared plus b squared. But we have a minus part on here as well. So it's going to be minus 2ab cosine of gamma. Remember, I usually use the gamma to represent the angle at C. Now, we typically, when you see this stated, you see it as C on the left-hand side and A and B on the right-hand side. But really, I like to think about it as rotated around. You can put A on the left-hand side and have B and C on the right-hand side. So you would have, the equivalent for that would be A squared is equal to B squared plus C squared minus 2BC cosine of alpha. So notice that here we had the C going with the gamma here. We have the A going with the alpha here. You can do the same thing with the B and the beta as well. It works for, the whole point of this is that it works for any of the sides. Okay, so if you think about your congruence theorems from geometry, we use the law of cosines when we have two sides and an included angle, or if we have three sides. These two tell you that you want to use law of cosines. So notice, was there a question? I'm sorry. Thought I heard something. Okay. So notice in this case that we have two sides. This is side A. Your 29 is your side A. And you have side B. You have your 13. So I've got the two sides, and the included angle here is gamma, the one at C. So I'm going to use that first version of the formula to help me figure out what C is. So law of cosine says we have C squared equals A squared plus B squared minus 2AB cosine of gamma. Now we're going to just plug in the different values. I have A is 29, B is 13, and so I get the 29 and the 13 also in that second term. And my gamma, in this case, is 41 degrees. So now I can use the calculator to help me simplify this right-hand side. So I'll just type in 29 squared plus 13 squared minus 2 times 29 times 13 times cosine of 41. And we get 440.948, oops, it was like 9490. Okay, don't erase them. And then to find C, we'll take the square root of both sides. So I'll do second square root and then second answer. And we get C is approximately 20.9988. And that's what this particular problem asked for, but I like to make sure that we know how to solve the whole triangle. So now we have our C is 20.9988. Now we should be able to figure out the other parts of the triangle. We should be able to figure out the alpha and the beta. Let's figure out the alpha here first. So if I want to do alpha, we can use law of sines or law of cosines to do that. It doesn't matter. Let's do it with the law of cosines, just so that we get a little bit more practice with it, because we did law of sines last time. So if we wanted to do law of cosines with this one, we want to figure out the alpha. The formula with the alpha in it for law of cosines has the A on the left-hand side. So we would have A squared equals, oops, B squared minus 2AB cosine of alpha. I know the A is 29.
Wouldn't it be 2BC?
Oh, yep, thank you. It would be 2BC. Thank you. I'm glad someone's awake this morning, because clearly I'm not. B is 13. The C is what we just found, that 20.9988. So put those in for the B and C. And I don't know what alpha is. So now going back to the calculator here, we have 29 squared. On the left-hand side, we get 841. And 13 squared is 169. That 20 point, I'm going to put 9. I'm going to put the whole thing in there just to try to minimize the rounding errors. Gives us 440.9489765. I'm just trying to minimize rounding errors as much as possible. I wouldn't, usually I keep these things in my calculator and I would not write them all on the paper. And then if I do 2 times, oops, not on the calculator part. If I do 2 times the B is 13, the C is the 20.99878512. We get 545.9684131, and that's still times the cosine of the alpha there. So I want to solve for cosine alpha. I'm going to do a couple of steps at once. To get cosine alpha by itself, I need to subtract these two values to the left-hand side and then divide by this coefficient. So I need to do 841 minus, good grief, keep not clicking over on the calculator before I start typing on the keypad, sorry. 841 minus the 169 minus that 440.94897. Oh, 9489765. So that's moving these two numbers over to the left-hand side, and then I need to divide by that 545.9684131. And we get 0.42319. And so to get alpha by itself, then we'll do the inverse cosine. So on the calculator, then I'll do second inverse cosine. And, oops, I hit the wrong thing. Second inverse cosine, second previous answer. And get approximately 64.9635 degrees. And now I can finish off solving the triangle because we know one angle is 41 and one angle is the 64.96, and we can figure out, we should be able to figure out the other angle by doing 180 minus that. I must have made an error somewhere in here because that number doesn't make sense. What error did I make? Oh, I know what error I made. Let me go back up here. I knew I made an error, and here's how I knew I made an error. This is actually a fortuitous thing that I made the error. So notice that this angle, alpha, is across from the longest side. Right? This alpha is across from the longest side of this triangle. So because 29 is the biggest. If this angle then has to be the biggest angle in the triangle, and I noticed that when I do this 64 and 41 together, and if I found the beta was going to be bigger. So that's how I knew I made an error, because this has to be the biggest angle. The error that I made goes back over here. Notice that I had a minus.
Does it have to be above 90 degrees?
In this case, it's going to have to be above 90 degrees just by the way the picture looks. But yeah, it'll have to be above 90 degrees in this case. The error that I made was I forgot to put the minus sign over on my calculator over here. I forgot to I didn't divide by the negative 545. So I can fix that by going back in here and doing the negative of 0.42319485552. Yeah, so this should be negative here, and that should be negative there. This should be 115. Notice it's 180 minus that. And you were exactly right. It should have been above 90, which we could tell from the picture, but in general, it has to be the biggest angle, and it wasn't going to be when I solved for it. So I knew I had made an error. So the error wasn't intentional, but it was a good thing that I made it, because I wanted to point out later that it's important to know that the biggest angle has to be across from the biggest side when you're doing these. So if you're getting an angle that's too small, it's probably the supplement that you need, the 180 minus that, which is exactly what we saw here. All right, so now we can figure out the last one. Our beta will be 180 minus 41, and then minus the 115.0365. So if we go over here, do the 180 minus 41 minus 115.0365, and we get 23.93, oops, sorry, 635 degrees. So this number for C, this number for alpha, and this number for beta solves the triangle. Any other questions on that one after I made an error on that one? Like I said, it was a good error to make because it illustrates making sure that you can check a little bit with these things, because I knew that my alpha had to be the biggest, and I could see that it wasn't going to be the biggest when I was done. So I knew I had made an error somewhere along the way. All right. Let's do another one where it starts with 3 sides given to you rather than 2 sides in the included angles. So let's look at number 7 here. And by the way, there's 24 problems on this sheet that I have that I'm working through here. I did answers to all of them, and they are uploaded on Moodle already. So if you want to go back and look at solutions, all of them are up on Moodle so that you have lots of examples to look at on here. All right. So this one, we're given 3 sides. So regardless of what the instructions are saying for you to do here, I want to solve the triangle. So I'm going to have 3 angles to try to find. And in this scenario, I would encourage you greatly to find the biggest angle first. It'll keep you from getting things screwed up later if you always try to find that biggest angle first. Okay? So in this case, the biggest angle is going to be at alpha because it's across from the 14. So I know that this is going to be my biggest angle. So I'm going to try to find that one first. So this alpha involves the a, so we'll use the version of our law of cosines. That's the a squared equals b squared plus c squared minus 2bc cosine of alpha. The a is 14, the b is 9, the c is 6. 14 squared is 196. I'll put the 9 squared and the 6 squared together. 9 squared is 81 and 6 squared is 36. So this part will be 117. 9 times 6 is 54. Times another 2 gives me 108. We want to isolate the cosine alpha, so we will subtract the 117 over. So we do 196 minus the 117. You get the 79 over here. And then I'll divide by the negative 108. In this case, make sure I include that minus sign. That's important. We saw that in the last problem. That was the error that I made. I forgot my minus when I divided it over. And now do our inverse cosine of both sides. So I can do that over here on the calculator. I'll do inverse cosine of the negative of the 79 divided by the 108. And we get approximately 137.0107 degrees. And this is absolutely going to be the biggest angle in the triangle because it's obtuse. It's greater than 90. You can't have 2 angles in the same triangle that are both bigger than 90. That was going to have to be the biggest one. All right. So now we just need to find the other two angles. It doesn't matter if you use law of sines or if you use law of cosines. Typically, I use the law of sines. I know in the previous example, I used law of cosines to find the angle. That was just to show you give a little bit more practice with the formula. This one, I'm going to use law of sines. I usually use law of sines at this point because it's a little bit shorter as far as the formula goes. So let's use law of sines on the beta. We would have sine of beta, that would be over 9, because that's the side opposite, equals the sine of the angle we just found. So that's 137.0107 over the side opposite is 14. Multiply both sides by 9. And then I would take the inverse sine of it. I mean, you can put in the number, you can type this in your calculator as you go along if you like seeing the numbers. I personally prefer to do it all at once. Because I already have that 137.0107 typed into my calculator over here. So now I can type this in. I do inverse sine, 9 times sine of the previous answer, and then divide that by 14. And that gives me my beta is 25.9980. If I round to 4 decimal places. And now finally, for gamma, once I find the two angles, the gamma one's easy because I just need to subtract it from 180. So going back over to the calculator, we'll do the 180 minus the 137.0107 minus, and then I'll do previous answer because it's already typed in there for me, 16.9913. So these three angles are what we needed to solve that triangle. And again, just as a quick check to make sure these answers make sense, the 137 degrees is across from the largest side, and the 16 degrees, closer to 17 degrees, that's the angle that's across from the smallest side, so it should be the smallest angle. Again, it's a nice check to make sure that at least the numbers are consistent with the way the triangle is set up. Any questions on that one at all? Let's see if we can do another one here. Go down where we don't actually have the triangles drawn. Like I said, these are all on Moodle as well. Here we go. So let's just look at this number 19 here, where they give you triangle ABC. This looks a lot like the last one we just did. Actually, those are the exact same numbers as the one we just did, so let's not do that one. Literally just did that problem. Let's look at this one for QRP. I'm just going to label them this way because I like it better in alphabetical order. So PQR here. The side P, which is the one that's opposite angle P, is 28. Side Q, opposite angle Q here is 12. And side R is 18. And again, just to use the same alphas, betas, and gammas that we did, I'm just going to use alpha, beta, and gamma here, just to, and notice I put them in that alphabetical order idea. So thinking of this as A, this is B, and this is C. All right. So like I just mentioned in the previous problem, since we're looking for an angle here, I always try to work with the biggest one that I can find, and I know that the angle that's opposite the biggest side will be the biggest angle. So the 28 will go on the left-hand side, and we'll have 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of alpha. So again, remember the side opposite and the opposite angle, that's where those go in your law of cosines. The other two sides are what fills in the other pieces. So it's the two sides and the included angle that are on the right-hand side. All right, so 28 squared is 784 on the left side. We have 12 squared is 144, and 18 squared is 324. So we get 468 here. 2 times 18 times 12, we get 432 here. We're going to isolate the alpha, so I'm going to solve for cosine alpha first. So we'll subtract the 468 over. So when you do the 784 minus the 468, I added apparently, 784 minus the 468, you got 316 on top, and you're going to divide by negative 432. And then we'll do inverse cosine of both sides. So going back over to the calculator, negative 316 divided by the 432, we get, this must be, of course it is. So we get 137.0107. And then again, to find your other angles, you can use law of sines or law of cosines to do that. Doesn't matter which. Welcome to use either. So let's say let's just use law of cosines again just one more time for practice. And in this case, I'll find the gamma. It's the next biggest angle. So the side across from gamma is 18. So we would have 18 squared equals 12 squared plus 28 squared minus 2 times 12 times 28 times cosine of gamma.
Professor Sticky?
Yes.
Why is gamma in the top? You know, it's usually in the bottom left-hand corner of the triangle.
I just put it at the top because I was just going in alphabetical order. Since it was P, Q, R, I went alpha, beta, gamma. As long as I have different letters for them, it really doesn't matter. I just did it in alphabetical order. It was just the way I drew it. I'm sorry, I wasn't trying to be confusing. I just drew it that way.
Okay.
Yep. All right, so your 18 squared here is 324. Your 12 squared is 144. And we just did 28 squared a minute ago. That was 784. And if we go over to the calculator, if I do 2 times 12 times 28, oops, 28, we get 672. And now again, we'll isolate our cosine of gamma. So I need to do 324 and then minus that 144 and the 784. So we'll have cosine of gamma is equal to, we got a negative 604. And we'll divide it by a negative 672. So we have 604 over 672. We'll do the inverse cosine of that. So we'll do inverse cosine of 604 divided by 672, because the negative signs cancel in that case. And we get 25.9980, again rounded to 4 decimal places. And then the third angle is always the easiest one to solve for, because we just need to subtract the other two from 180. And that gives us, so I'll do the 180. Oh, crud. I keep doing that. I keep forgetting to click on the calculator before I start typing on the keypad. And we get the 16.9913. And again, those angles match up with the lengths of the sides, right? The smallest side was 12 for the one that was across from the thing I called beta. And so I have the smallest angle there. So all those things match up.
Professor Staples?
Yeah.
I don't know if it's a coincidence, but these are the same exact numbers that we got for number 7.
Yep, they sure are. Yep, they are. I didn't notice that before I started working on the problem, or I would have done a different one. Notice that the sides in number 7 were 6 and 14 and 9. Those were the side lengths they give you in number 7. Notice that each of these sides are 2 times as big, right? So I had similar. So these triangles were similar to each other. So the angles were going to be the same. That's why they were exactly the same numbers. It didn't register in my brain before I started working the problem that they were the double the numbers that we had started with until we did the first angle. And then I'm like, oh yeah, it's the exact. We're going to get the exact same numbers. So you're exactly right. That's a very good catch. It was the same thing. It's because they're similar triangles in this case.
So we'll be doing another one?
Yeah, we can do another one. Absolutely. Let's just do the one right below it, since it actually has 3 sides and not similar to the previous one. Like I said, I didn't even notice. I grabbed this worksheet off the web because there's 24 problems in it. It's like, oh, there's lots of examples. Well, apparently there's not lots of different examples because it's literally the same problem. All right, so let's do DEF, and then our D is 12. That's the, and our E is 16, and our F is 17. And again, just for alphabetical order's sake, I'll call alpha the one by D and going around in alphabetical order from there. All right, so same idea. Let's find the biggest angle first. So the biggest angle, again, here happens to be across from the gamma. So we'll do 17 squared is 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of the gamma. And again, the pieces that correspond are the opposite angle and side that are on opposite sides here. The other 2 sides are how we fill in the rest of the formula. 17 squared is 289. 16 squared is 256. 12 squared is 144. And let's see, 32 times 12 is 384. All right, so in this case, we want cosine of gamma, so we'll subtract the 256 and the 144 over. So if I do that, the 289 minus the 256 minus the 144, we get negative 111, and then divide by the negative 384. So that gamma will be the inverse cosine of 111 over 384. Oops, so 1982 degrees. So we got our gamma is 73.1982 in this case. And then I like to solve for the biggest thing that I can at any given time to make sure that I'm not dealing with, oh, I need to do 180 minus something because it needs to be the biggest. If I solve for the biggest each time, then I don't have to worry about it if I'm able to. So that means in this case, I'm going to solve for beta next because it's opposite the next biggest side. And just to mix it up again, just a review from what we talked about last time, let's use law of sines. The sine of the beta over the 16. You can use law of cosines, it doesn't matter. I just find that the law of sines is shorter. It's a smaller formula. Sine of beta over the 16. That's going to equal the sine of the 73.1982 over 17. So that's the angle we just found, the gamma, over the 17. So then I just need to get beta by itself. So we'll multiply both sides by 16. And divide by 17. And then do the inverse sine. Again, if you're a person who likes to simplify the numbers first before doing the next algebraic step, that's fine. I personally prefer just to type it in all at once, so I don't have to type in several different things. So inverse sine, 16 sine of previous answer. The previous answer was our angle here, so just it's the sine of the previous answer and divide by 17. In this case, we get about 64.2895. So we've got the first two angles. And notice again, like I said, as I'm checking and I go, this one should be the biggest angle. This one should have been the next biggest angle, which is exactly the order they are in. And then doing my alpha now, we'll do the 180 minus each of them. So back over to the calculator, if I do the 180 minus the 73.1982 minus, in this case, I'll just hit previous answer because it's in there already. Get 42.513 for the last one. Any questions on that one at all? Let's see if we can do an application problem. I don't think I have those up here, so let me see if I can get it added real quick. I don't remember where I have it. Oops, that's not the right folder. Just so we can see some applications here. This applications thing is also posted on Moodle. I thought I had them in here. Let's see if it's this one. Yep, there it is. Those are applications. Cool. That was what I wanted to see. All right, so this should also be on Moodle with the solutions. So I just wanted to do a couple of applications here to see if we can figure out the different pieces that it's asking for in the different applications. So this first one, we've got a balloonist over an island. So we got some island here. I'm not going to try to draw pictures. Here's the island. The balloonist is over the top of the island. Okay, so we've got an angle of depression to the, let's say this is the north side. So it says the angle of depression to the north side is 32 degrees. So remember, angle of depression is if you're going out from the horizontal and looking down. And it says the angle of depression to the south side is 47, that way. And also determine that the distances to the south and the north from where the balloonist was were those numbers here. So this is, if this is south and this is north, just to label these again. This side to the south side was the 2825, and this side is the 3880. The problem now asks basically how long is it from the north side to the south side of the island. So in this particular problem, notice that we're given two sides. Draw them in red here. We're given this side here, and we're given this side here. And we also have enough information to get this angle here, right? Because I know that if this one's 32 and this one's 47, this whole if I put it together with this one, we have to make up a straight line, which means this has to add up to 180 degrees. So if I go over to the calculator, if I do 180 minus 32 minus 47, this angle here has to be 101, again, because I have to make up a straight line. And then finally, we're looking for this side that's on the opposite. So just for lack of a better letter, I'm going to call it C here. So notice I have two sides and the included angle. So that's what's telling me I want to use law of cosines to figure out what C is. And in this particular problem, it's not asking us to solve for the whole triangle. It's asking us just to find the side. Now, we could solve for the triangle. It'd be really easy because these two angles are the same and those two angles are the same. But this one's just asking us for the C. So using our law of cosines formula now, we would have C squared. It's the other two sides, so it would be 3880 squared plus 2825 squared minus 2 times 3880 times 2825 times the cosine of 101 degrees. So let's just do the individual pieces here, make sure we don't mess up any numbers. 3880 squared is big. 105, no, I can't read. 1505, 4400. 2825 squared is 7980625. And then multiplying the last things together, 2 times 3880 times 2825 times, that was weird, that was really weird, it stopped my screen share, sorry about that. The 2 times the 3880 times the 2825 and then times the cosine of the 101. And that's going to give us, it's going to change this minus sign to a plus. 418,2914.797. The reason why the minus sign got changed to a plus is because the cosine of 101 is going to be negative, so I changed it to a positive. So to put all these things together then, the c squared will be, if I do 1505, I keep doing that. Sorry about that. 1505, 4400 plus the 79,80625 minus the previous answer, because that'll change it to a plus. Gives us 272,179.39.8, and then do the square root to give us 5217.0815, and that's going to be in feet. So notice that we use the law of cosines here to help us figure out what that third side was. So we got I just drew the triangle to start with and got the sides labeled so I could figure out, do I want to use the law of cosines or do I want to use the law of sines to figure out the answer in this case. Any questions on this one? Okay, so again, this worksheet is posted on Moodle with answers, plus all of the law of cosines problems that we started working through on the other worksheet that I had open. All of those solutions are done, and all of those are on Moodle as well as the blank file. So if you want to work through it and check your answer rather than just reading the answers. So all of those are in there. There's also an additional review of law of sines and cosines problems on there, as well as there should be an additional review video on YouTube as well, going through different things with law of sines and law of cosines. So lots of resources for laws of sines and cosines for you to go through. Again, we won't meet as a class on Friday like this. We will, but I will definitely be available if you want to email or if you want to set up a Zoom meeting, either of those two things. Also, one last thing, I'm going to send out a survey. I would like to, basically it's just a short little survey. I just want to know how things are going, how you feel like things are going, so that I can get a feel for if there's anything I need to change going forward. So I'll be looking for that this afternoon. I'll get that sent out. But otherwise, if there's nothing else, I will talk to you all later. And I'll talk to you probably on Monday. Have a good one.